Lab 2, free fall acceleration and drag. In this lab, we first record a video of one dropping an object at a recorded height in order to absorb free fall acceleration. There's no velocity in the x direction. Next, we develop data using tracker to analyze the position at several points in time in order to compute the velocity in which the object is traveling. These data points end up showing a constant acceleration, which ends up being gravity. Then we use GlowScript to code a predicted computational model of the object's acceleration without drag and with drag to see how it compares with the observed data. Here's a picture of my tracker. These are the dates corresponding with position and time, and notice how it's a curved line, which indicates that there's an acceleration. And this is where I dropped it from. Ideas being tested. The ideas being tested in this lab were gravitational forces compared to acceleration, and the mass of the object also considered considering the derivative of the velocity data points that were measured. For the gravitational force to equal mg, there has to be no drag force that acts against the object, which is not possible in real-world conditions. Acceleration is velocity over time. Reasoning. The reasoning in order to get acceleration is because we need to get the velocity at instantaneous periods of the objects falling to get an idea of what the acceleration is. Without drag force, it would be 9.8 meters per second squared. Here's a picture of the velocity versus time graph of the model where there is no drag, which is a constant acceleration, and the model where there is a drag, the drag force, which shows that there's not a constant acceleration. Surroundings, conditions, details, and errors. The surroundings for the experiment was a library room, and the object was dropped exactly at my height. There is air resistance when the object is dropped, which makes my acceleration going down non-constant. Another error is me dropping the object could have a very slight push downwards, adding another force other than the gravitational force. Initial conditions are me dropping an object from my height. The object is a Birkenstock slipper weighing about 170 grams. Here's the code snippets. This one would be where there is drag, and then this one's where there's no drag. So for the code, I first changed the time to the ending timestamp of my video, which is just my delta t. For the first glow script, I left b equals 0 to leave no air resistance. And for the second glow script, I made b equals 100 to correspond the air resistance coefficient to match the observed data that I found. And also in the code, I included the position and velocity update formulas. What if and what does it mean questions? When terminal velocity is achieved, the net force is equal to 0. This is because the force of gravitation and the force of air resistance are equal and pointed in opposite directions. The object can still reach terminal velocity because the added force downward plus the gravitational force can still equal air resistance if the force is strong enough, going the opposite direction. And this is my model for this line would be the observed model, which I found. And then the red line would be the expected model y with drag. And notice how these two are more similar, which means that this line showed that there was drag. And the yellow line would be expected model without drag. And this is based on position versus time. Thank you for listening.